Hi everyone, we're presenting a capstone project on redesigning an export-ready ketchup bottle for JestFoods Industries. The main issue is that the current bottle could not handle hot fill processing at 85 to 90 degrees Celsius. As the ketchup cools, it creates about 18.7 kilopascals of inward vacuum pressure, causing the bottle to buckle. This affects both the structure and shelf appearance, so our goal was to create a stronger bottle that can survive hot filling and look suitable for export markets. JestFood Industries is based in Kampala, Uganda, and produces tomato-based ketchup and sauces. As they expand into export markets, their packaging needs to protect the product and improve shelf appearance. Our project focused on three objectives: redesigning the bottle geometry, selecting a suitable material, and validating the final design. The bottle needed to withstand hot fill temperatures, keep deformation below 0.5 millimeters under vacuum load, and remain practical for manufacturing and cost. We evaluated six materials using a weighted decision matrix based on the temperature resistance, availability, cost, and sustainability. Consumer survey results also showed a preference for a transparent or translucent bottle. Based on these factors, we narrowed the options to HDPE, standard PET, and heat-set PET for further testing. For the redesign, we developed several sketch concepts exploring different bottle features. The final CAD model combined the strongest design features, including a more stable body shape and indented side panels. Compared to the original bottle, the redesigned version improves both structural support and export-ready appearance. We then validated the design using SolidWorks simulation. Each shortlisted material was tested under the same 18.7 kilopascal inward vacuum load. HDPE filled with 1.177 millimeters of deformation, while standard PET and heat-set PET both had deformation of 0.437 millimeters. However, standard PET was considered marginal because its heat resistance is close to the hot fill temperature range. Heat-set PET met both the structural and thermal requirements, so it was selected as the final material. Overall, most engineering requirements were met. The final design withstands hot fill temperature range, staying within the deformation limit, maintains the required bottle capacity, and meets food contact compliance expectations. The only requirement not fully met was the target cost of under 30 cents per bottle, but the estimated cost range is still competitive compared to JustFood's selling price of $1.85 per unit. The final design achieved a maximum deformation of 0.437 millimeters under vacuum loading, which confirms that the bottle can maintain structural integrity during hot fill conditions. Cost is slightly above target but still competitive depending on material quality and sourcing. Most importantly, the design is export ready. It meets FDA and Codex standards and is scalable for manufacturing. Overall, this project provided JestFoods with a stronger and more reliable bottle concept. By improving the geometry and selecting heat-set PET, we addressed the deformation issue while improving packaging quality. Thank you.